Alright, so today we're going to take a look at Unit 6, Day 2, more practicing with exponents. Okay, so this is going to be a little bit different than yesterday, but the same basic ideas are going to hold true here. Alright, now before we get into any of the new stuff here, let's do a quick recap of yesterday with a problem like example 2. Or how about exactly example 2? So, like everything we're going to see in this chapter, the directions are always going to be the same. All right, we're going to see a rational expression like this, and we are just going to want to simplify. All right, so that means cancel, get rid of as many things as possible. Okay, all right, so before we do anything, we got to take a look and see -2, -5, -9, -4. You know what we call these guys? Those are our sad guys. Aw, they're sad. They don't like where they're at. Okay? So what do we have to do with sad guys? We gotta send them on a vacation. Help them take their mind off things. Okay? So every single term with a negative exponent needs to move somewhere. So x to the -2nd, z to the -5th. Both of these guys are in the numerator, right? They're kind of like up in Minnesota. Where it's very cold. Sorry, I've been watching a lot of Fargo. But both of these guys need a vacation. Okay? So we're going to send both of these down to the denominator. However, x to the -9th, y to the -4th. They are down in the south. Maybe they're in, like, I don't know, Florida. Florida's not that great. Not that great of a state. Okay? So both of these, we're going to send them up. Okay? A little change of scenery never hurts anyone. All right? So let's do that first. So everything else that didn't have a negative exponent stays exactly where it is. That includes the 63 in the numerator. Okay? In the denominator, there was a 3, and there was this z term at the very end, right? This z right here did not have a negative exponent, so we're going to leave it in the denominator. Everything else is going to get flip-flopped, okay? So, what's coming up from Florida? X to the 9th, and y to the 4th power. And what's going to come on down? X squared and z to the 5th. Okay? So now let's take this expression and let's try to simplify it. So remember, with simplifying, our goal is to go piece by piece. Okay? So let's start off with our numbers. All right? So we have 63 divided by 3. Okay? Now you can go ahead and do this in your calculator, right? That is going to give you 21. You may not have needed a calculator to do that. That's okay. All right. So the numbers have been fully simplified. Okay. Let's move on to our x's. So we have x to the 9th divided by x squared. Okay. We're dividing x's, right? And so that means we are going to go ahead and subtract the exponents. So 9 minus 2 gives us 7x's. And those are going to stay in the numerator, right? Because we started off with more x's in the numerator than we had in the denominator. Okay? All right, let's keep going. Y to the 4th. Aw, y to the 4th doesn't have a friend. That's okay. It's not sad, so we're going to leave it up here. All right? And now, what's left? Let's go into the denominator. We have z to the 5th times z. Okay? Now, this z term right here has no exponent. And if it has no exponent, that means we can go ahead and write in a 1. So, this is z to the 5th times z to the 1st. When we multiply, we're going to go ahead and add the exponents together. And so we get z to the 6th in the denominator. Okay? And so my final answer has one reduced fraction, right? 63 over 3 is 21, right? It has one x term, it has one y term, it has one z term, okay? That's your goal in simplifying. You want one of everything. Put it together, you get this nice, beautiful package, okay? So, this is what we talked about yesterday, all right? And now we're going to take this concept and apply it to something slightly different. So, now let's take a look at example 1. Okay, now example 1 still has variables, okay, but it also has something a little bit different, right? It doesn't have just an x, just a y, just a z. It has expressions. It has x minus 1, that entire quantity, x plus 2, that entire quantity, x plus 4, that entire quantity, okay? And so we can treat each of these like their own variables, okay? And so we can still use the same properties, all right? So, first things first, any negative exponents. Any sad guys? Let's see, 3, no, x minus 1, no, x plus 2, no, 18, no, x plus 4, no. No negative exponents. Everyone here is happy. Go ahead and put on a Pharrell song. As a side note, not a big fan of that song, okay? Let's be real for a second. That's not that good of a song. Okay? I'm sorry. It had to be said. Moving on. Okay, so now let's go ahead and do what we did last time, right? Let's start off and have a simplified fraction. So 3 over 18. Okay? Now, most people just want to go ahead and call this 6. Now be careful. If you did 3 divided by 18, in your calculator, right, you would definitely not get 6, okay? You would probably get 0.166666667. That's a rounding error at the end, okay? That's because this is 1 divided by 6. All right, 3 and 18 are both divisible by 3, okay? All right, so moving along. That part was simple, okay? Let's talk about x minus 1. Now, we have an x minus 1 in the numerator and an x minus 1 in the denominator. Okay, so what are we going to do? We're going to do the same thing we did in example 2, right? Whenever we have two of the same, whether it's just a variable or an entire expression, we're just going to apply our properties of exponents, right? So when we're dividing, we subtract the exponents, okay? So let's go back and see what we can do here. All right, so x minus 1, I can think of that entire thing as being to the first power. And this other x minus 1, I can think of that entire thing as being to the first power. So when I subtract those exponents, I get 0. In other words, these cancel out. Okay? Right? X minus 1 divided by itself, right? Anything divided by itself, that whole thing is just 1, so those cancel out. Okay? Now, x plus 2. Do I have an x plus 2 anywhere? Nope. So, that is going to stay in the numerator. Okay? And one more here. We have x plus 4. Do we have an x plus 4 anywhere? Nope. So that is going to stay in the denominator. Okay? And so let's look and see what I have. 3 over 18, we reduce that to 1 over 6. X minus 1 divided by itself cancels out. Okay? X plus 2 divided by x plus 4. Now, here's what most people want to do. Most people want to go ahead and cancel out the 2 and the 4, right? You can go ahead and reduce that. Or, I can cancel out x and x, right? Wrong, okay? This is different than what we were just doing, okay? When you have these little expressions in parentheses, all right, these can only cancel out with the exact same expression. So x plus 2 is in its own parentheses. It can only, do stuff with another x plus 2. Same thing with x plus 4. All right? So there's not much else we can do here. And so this is our final answer. Okay? Now, there is one other thing we can do, but it's not really necessary at all. So if you do this, it's fine. I won't take off for it. It's just not really super helpful, right? You can take the numbers in front and you can go ahead and distribute them if you really feel like it. 1 times x plus 2 is just going to be x plus 2. 6 times x plus 4 is going to be 6x plus 24. Okay? And now, again, you can think of each of these as being in their own parentheses. So here's another acceptable answer. Now, don't get crazy here and start canceling 2 and 24, or the x and x, right? X plus 2 can only cancel out with another x plus 2. 6x plus 24 can only cancel out with another 6x plus 24. Okay? So this is the type of stuff we're going to be looking at today for the most part. All right? Okay, so let's move on. Okay, so let's jump ahead to example 4. All right? Now, example 4 is what we like to call a hodgepodge. Okay? There's a lot of stuff going on here right now. Regardless of every little bit of craziness in here, okay, we're still going to start off the same way we did example 2, okay? I see all these negative exponents, and I ask myself, why are there so many sad little guys in the world, okay? All these negative exponents, they all need to take a vacation, right? Z to the negative 5th, it's living up in Seattle. It rains a lot up there. The coffee's overpriced. The Mariners aren't that good. It needs to come down and take a vacation. Okay? X minus 4 to the negative 4th power. Again, if it's in the south and it's upset, it's probably living in Florida. So we're going to send it up north. Okay? So everything else here does not have a negative exponent. Don't touch it. Okay? So let's rewrite this, moving only to things with negative exponents. So, the 4 in the numerator, that's going to stay where it is, right? X minus 4 squared, that's going to stay where it is. Y to the 9th is going to stay where it is. In the denominator, 48 is going to stay where it is. Z squared is going to stay where it is. And y to the 8th is going to stay where it is. Okay? So let's see, what is going to move up? Only x minus 4 to the 4th power. And what's going to come on down? Z to the 5th. Okay, so now I look at what we have here, no negative exponents. Okay, so now let's start simplifying. All right. So we're going to go ahead and start with, as always, our numbers. What is 4 divided by 48? Now be careful. Some of you might think, oh, cool, 12. Okay, not quite. The smaller number is in the numerator, right? So this is the reciprocal of 12, which would be 1 over 12. Okay. So now, let's go ahead and move right along. We have x minus 4 to the 2nd power. Is there another x minus 4 somewhere? Why, yes, there is. Huh. Isn't that super convenient? X minus 4, right, was a sad guy. It was living down in Florida, but we moved it up, and now it has a positive exponent. So x minus 4 squared times x minus 4 to the 4th power. When we are multiplying, right, because they're both in the numerator, so they're being multiplied, we go ahead and we add the exponents. So 2 plus 4, gives us an exponent of 6. Okay, let's keep going. Y to the 9th, stuck there in the middle in the numerator, right? Do I have another y somewhere? Why, I certainly do. Y to the 8th in the denominator. Okay, so y to the 9th divided by y to the 8th. When we divide, we go ahead and subtract the exponents. 9 minus 8 gives us y to the first power. And again, just like in example 2, right? I have more y's in the numerator than I have in the denominator, so my answer is going to go in the numerator. Okay, and it looks like we got one more thing hanging around here, right? We got these two z's in the denominator. I have z squared and z to the 5th, right? Now, just like x minus 4 squared and x minus 4 to the 4th, right? They're in the same part of the fraction, so they're being multiplied. So z squared is going to be multiplied with z to the 5th. We're going to add exponents and get z to the 7th. So my final answer, right, we have one reduced fraction. We have one of the expression x minus 4. We have one y term, and we have one z term. I call that a job well done, ladies and gentlemen. Okay, all right, let's keep going. Okay, one more to take a look at here. All right, example 5. So, just like we always do, right? First thing, let's get rid of all of these sad guys. So many sad things in the world, right? We're going to do our part, okay? Anything in the numerator, living up in Seattle or Minnesota, or how about Maine? Is there anything in Maine? Rocks? Cattle? Is there anything else? Anything? I don't think so. Okay, we're going to send it on down south for a vacation. Okay, x plus 2 to the negative 3rd, x minus 4 to the negative 7th. Both of these things need to get the heck out of Florida, just like everyone else. Okay, a lot of Florida hate today. That's all right. We're going to allow it. We're going to move those on up north. Okay, and as always, everything else without a negative exponent is going to stay exactly where it is. So 4x cubed is just fine where it was. X minus 4, just fine where it was. 2x to the 7th, just fine where it was. Okay, and now let's do some switcheroos. Okay, so my two terms from down south are going to come on up north to Yankee country. Sorry about that. So we're going to have the quantity x plus 2 to the positive 3rd power, and we're going to have the quantity x minus 4 to the positive 7th power. Moving on up to the numerator, and then what took the plunge down south? X plus 2, and now that is going to be to the positive 5th power. Okay, so I do certainly believe we are ready to simplify. Alright, so what do we got here for starters? 4 divided by 2. That's a nice easy one here. That's going to be just 2. Okay. Alright, moving right along. We got an x cubed divided by x to the 7th. Okay, so as always, when we are dividing, we are going to subtract the exponents. 7 minus 3. Now take note, this is the first time we've seen this today, right? We have more x's in the denominator, which means I should write x to the 4th in the denominator, not in the numerator. Okay, very common, very easy mistake that people make. Okay, let's keep going here. We have x minus 4, And I have another x minus 4 that came from the south, right? That's to the 7th power. And so these are both in the numerator, right? X minus 4 to the 7th, okay? Now, x minus 4 doesn't have an exponent, so we can go ahead and put in a 1, right? So when we go to multiply, we can add our exponents. We get x minus 4 to the 8. That's 8 for our non-Spanish speaking friends in the audience. All right. And looks like we got one more to deal with. X plus 2 to the 3rd power over x plus 2 to the 5th power. Okay, so dividing, we're going to go ahead and subtract. 5 minus 3 is going to give us an exponent of 2. And again, looks like we have more in the denominator, right? We have 5 down here versus 3 in the numerator, okay? And so we're going to go ahead and put all of those in the denominator. 5 minus 3 gives us an exponent of 2. Okay, so what does my answer have? 4 divided by 2, 1 reduced fraction. X's, right? I have 1 reduced x. X minus 4, x minus 4. I have 1 x minus 4 term. X plus 2, x plus 2. I have 1 x plus 2 term. And this is what we call a mighty fine answer. Okay, and this is very happy, despite the poor mouth drawn there. Okay, all right, nicely done, everyone. Okay, so homework is going to be worksheet 2, and I will see y'all later.